Hello everyone, my name is Ahmad Ridhwan Mohammad Kamil. I'm a master student from Universiti Teknologi Malaysia. I'm currently attached to the Center for Artificial Intelligence and Robotics. I'm gladly to present my work on path planning based on inflated medial axis and probabilistic roadmap for Duct environment. As a starting point, let me share the motivation behind this work. Heating, ventilation, and air conditioning system is a system to provide air circulation for building. A contaminated HVAC system are more prone to spread biological and non-biological pollutants throughout the building that could cause the sick building syndrome. The size of the duct for HVAC system is small and confined, thus it makes human hard to inspect the condition manually. Another thing is that during camera inspection, in order to get the best viewing angle, the robot is required to maintain position at the middle of the duct. This will allow for better coverage on the inside of structure. Okay, now let's take a look on the problem characteristic of this application. For the characteristic of the environment, it can be described as it is a static environment, it is a narrow passages, and it is a confined space. For characteristic of our task, based on our application, the ducting is required to do a scheduled inspection and cleaning. Thus, it requires a map-based planner, a clearance distance planner, and also a multi-query planning capability. Now, let's take a look at our proposed approach. The core principle of the proposed method can be divided into three parts. First is a configuration space skeletonization. Second, inflation of the medial axis. And the third one is a probabilistic roadmap-based planner. For the configuration space skeletonization, we use map based on the occupancy grid map. Occupancy grid map is a well-known map type to be used for the navigation. Second one, we are using the iterative thinning algorithm to generate the medial axis. The generated medial axis has two or more same equidistant toward the obstacle. Next, for the inflation of the medial axis. This will inflate the medial axis to provide the region of constrained space during sampling process. The inflation process uses the radius as a parameter for the inflation. And lastly, for the planner, we use probabilistic roadmap to the path planning. As we know from the task characteristic, it is required to be done repetitively. And this probabilistic roadmap provides the capability to do a multi-query planning. Okay, this is an overview of our system. There's mainly two parts from our system. One is the skeletonized and inflation, and another one is the probabilistic roadmap. So let's take a look at our first block. So the first block is to acquire a map. Usually it came from the mapping process, such as simultaneous localization and mapping. And then it will be fit into our skeletonized and inflation process, which is firstly we will generate a medial axis using iterative thinning algorithm. After that, from the medial axis, we will inflate the medial axis to generate a region. After the medial axis have inflated, then it will be fit into our probabilistic roadmap planner. So firstly, it will generate a roadmap during sampling process, and then after roadmap is generated, and then it will be sent to the query process. This is the process where the user can input the goal position. And after the query process, the query process will generate a path trajectory. The path trajectory can be outputted as a list of waypoints that can be fit into a controller. Okay, now let's take a look at our detailed description of our algorithm. So for the part skeletonized and inflation process, the skeletonized is done using iterative thinning algorithm. As you can see from on the left side, this is the thinning process that is used to generate the medial axis. This morphological process is done using a MATLAB image processing toolbox, which is a morphological process. The thinning algorithm will generate a skeletonized of medial axis until it reach a width of only 1 pixel. After that, the inflation is only going to be done after the thinning process is completed. Next, let's take a look at the detailed description of algorithm for probabilistic roadmap construction. After the inflation has been done, and then the inflation region will be used as a sampling coefficient space. As you can see on the left side, this is the example of the overlay of the configuration space. So from the overlay of configuration space, we will use only the inflated region to construct a probabilistic roadmap. This probabilistic roadmap will be only generated inside the medial axis region. So from that, during a query process, the user will be inputting the goal position and the planner will try to query the trajectory from starting point to the end point using graph search method. After the graph search method has been done, the waypoint will be generated that can be fed into the controller. This is the example of the process. Okay, next for the experimental setup, we use a real constructed of mockup environment. On the right side, as you can see, is the video of how our map acquisition is done by using the simultaneous localization and mapping. For our system, we are implemented on MATLAB and also ROS. Okay, this is our experimental result. On the left side, as you can see, it is a conventional PM, and on the right side is our proposed method. As you can see from the conventional PM result, the generated roadmap is not constrained by the inflated medial axis. Because of that, the roadmap is generated nearer to the obstacle. And when we query for the path, the path is intends to find the shortest path and also generate a path that is nearer the obstacle. Next, when we compare to our proposed method, because we already constrain the configuration space towards the only inflation region of the medial axis, the roadmap is constructed more clearer distance from the obstacle. When we query the path trajectory is generated more clear and distant towards the obstacle. You can see the result on the right side. This is the experimental result. There's a two table here. The first table is the result of path clearance and success rate. Second is result of pre-processing and query computational time. This experiment was conducted for 1000 trials. As you can see from table 1, the proposed method generates a path which has better clearance distance. But for the success rate, as you can see, our proposed method show a bit disadvantage at 100 sample nodes. But in 200 nodes, it gives a better advantage at 99.9% compared to the classic PM, which is only 99.1%. Now let's take a look at the second result, which is the pre-processing and query computational time. For computational time, there are slight disadvantage of our proposed method, as it requires extra step during sampling process. As you can see here, but for the advantages of the probabilistic roadmap, that it only need to be sampled only once, and during the query process, as you can see, it's quite same except for the 200 node, because the 200 nodes is the complexity of the roadmap is greater than the classic PM. This is the constraint from the graph search method. Okay, so for the future works, the we would like to do a post-processing step to further optimize path planning and generate time optimal trajectory. We also intended to implement on 3D environment, as well as integrated with a fly robot, example quadcopter, as ducting also included vertical structure. Okay, thank you everyone for your attention.